Hey, Nathan here from PH Studios. Welcome back to part 2 of the maps tutorial. And in this tutorial we're going to discuss how to move a player across the screen and handle collisions in a very basic way. There's a whole lot of different ways you can do this. You can do it a whole complex, like 20 lines of code to detect collision, that type of stuff. But I'm just doing it a very basic way. Since this isn't any sort of complete game or anything, I'm just trying to do the basics. But even then, it took a long time to do. Alright, so like I said last time, I'm going to, for the player, I'm just using a stick figure. It's not that well done, but it'll demonstrate what needs to be done. And there's two players here. I'll demonstrate what this will do here. There's one that has pixels on left and right sides, and the other one I just deleted those and just left the player. So that is the actual tile dimensions of the entire map. That fits the tile dimensions. This does not. This is just the non-transparent pixels. Alright, so the map is similar. I created additional tiles here just to give it a little bit more lengthwise, and then I added a special character that defines the start location, which is pound. You can change this later and I'll show you how to do that. For now, let's put that there, and let's put it up here so I can demonstrate what happens if you put it way up top. So it's a pound symbol, number sign. Alright, so let's go and look at the game1.cs. Alright, so what's different from last time, I added the special starting location to the map. But then I also encapsulated the map object into a level object. So a level object has a player and a map. If you look at the level.cs, it has an active player and an active map. That's all the level has. So you can have multiple levels if you want to. And what you do here is you have a level 1, map 1, and I also have fade texture. I'm going to talk about that later. And fade color and fade amount. Okay, so what's different here is since I added that special character to identify the starting location, I had to add that to the constructor. So if you look at the constructor map, it takes content, a string file, a string tilesheet asset, a point dimensions, a character for empty tiles, and a character for spawn tile. So you say pound, that's where I want the player to spawn. You add regions just the same, and it will ignore the spawn tile. So you do not have to add a region for that. It'll add the background just the same. And then level 1, the constructor just accepts the map, and then there you go. Fade texture, just like the screen system in the later builds, this is not, you do not need the single pixel like you have since the pawn clone, I believe. That will just generate a 1 by 1, 1 pixel wide, 1 pixel tall texture that is any color of your choice. I chose color red because we already have the green, bluish type feel for that, so color.red kind of goes with that. And then we set the color data with the color array, and then we set the fade color as red. Load content, we need to load the player, and to do that we grab the player asset name. And I didn't do the player full, so this is just the player. Let me bring that back in there. Okay. So this is just a player, not the full tile. Then we unload content, we have nothing there. We update the level. And we update the level because we need to check collision. We need to update the player, and then we need to check collision. Then we draw the level. And if there is a collision, we draw that fading texture. So I will have a full screen of red, and then it's set to like 50% opacity, and then that way you can tell, or I'm colliding with something. It was just easier for me to identify and easier for you to see what's going on in the collision. Okay, so now let's talk about the level. The level, of course, has the player and the active map. In the constructor, it takes the map, and then it initializes the player based on the map. It gets the spawn location, X and Y, from the X and Y from the map coordinates. So this spawn location is 0, 2. And it will automatically detect the position. If you look at the player constructor, it'll detect the position of that. Position is equal to previous position is equal to vector 2 tile x, which is the 0 times width, tile width, how many tiles, or the dimensions of the tile, and tile y times tile height. So that's 2 times 36. So it converts the map location to the actual screen coordinates. And of course, if you're not that familiar with C#, this assigns both of those to the same thing. Position will equal this vector 2, and previous position will equal this vector 2. Okay, back to the level. So we initialize the player, we grab a new player object, and we set its location. Now we just need to get a local reference to the active map. And we update that. We check collision, we set it to false. We update the player, and for each point in the player.collision points, and I'll get to that later when we discuss the player class, for each of the collision points, we check if the active map is checking the collision, if that point collides with the active map and the player. If that's true, we handle the collision, and we set collision is equal to true. We loop through all those points, and then we set game1.collision is equal to collision. Okay, draw. We just draw the map and then draw the player. That's it. We always want the player to be on top. Alright, another new class is player, so let's discuss player. Now the player is going to have the texture, that stick figure, previous position and current position, just labeled regular position, movement, velocity, and acceleration. Those are vector 2s, as an int tile width and tile height to identify the width and height of the tiles in the maps. A float depth x and depth y. I'll discuss that in the collision here in a few seconds. It has a few constants that will never change. You have to change it in the code. So constant float gravity. As you see, when we have the players starting, it will automatically drop. I will not hold the keyboard. I will not press the down key. It will just drop. It has gravity. Speed, how fast it moves. And max speed, the maximum speed it can achieve due to gravity and speed. It has 2 keyboard states, a current input and previous input. That way, if you just want to do a single key press and not hold something down, you can do that. Okay, so now we have a list of vector 2s called the bound points. And this is private. There's no way to get to it outside of the class. So the bound points hold the top left, top right, bottom left, and bottom right of the texture. The actual location. So let me look at that. It'll look, the points will be here, 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 and here. But it'll be in screen coordinates. Let me exit that. Collision points. I'll discuss that later. Alright, so the constructor, we just initialize everything. We get the current state of the keyboard. We set the bound points. The maximum we can have is 4 because it has 4 corners. And collision points. It doesn't have a max value. Load texture. We're going to load the texture load the player.png into the texture, so content.load and then the asset name. Get tile location. We have two methods here. If you call get tile location without passing it anything, it'll assume you're wanting it from the current location. So to get tile location, we'll call get tile location and pass it the current position. Now what this will do is the position is the screen coordinates. So let's say 500 by 300. So 500 divided by tile.width, comma 300 divided by tile height. So that will get the tile location, the map point that you're located. And we do this for the collision. And we're just about there. Just give me a few seconds for the update. Just like the past few tutorials and past few keyboard stuff that we talked about, we need to reset the previous position to the current position. And then we can just do the current position update will be here. And I commented this out because we don't really need it. You can delete the previous input. I thought I would need it. If you want to leave it in there, just uncomment it. And maybe you have like a fire button that you want to fire something and you don't want to hold it down and fire 500 missiles. Something like that. Okay, so we have acceleration and we accelerate with the gravity. And then we have a movement vector. And what I did here is this was what was giving me trouble. I want gravity to be incrementing every time every loop. I want the velocity to increment every loop. So it'll get faster and faster and faster. So what I do here is I used to have a local variable called movement, vector2 movement. So what I did is I put that up in the field. So it now has a movement vector in the field. So whenever we increment velocity, if you want to have the gravity actual increase over time, which was I disabled it, but it's what it was there before. If you want it to increase over time, he's falling, but he's getting faster and faster and faster. What you do is at the beginning of the update loop, right here where I'm highlighted, you'll minus the movement vector. So you don't move faster than you should on gravity. So you subtract the movement vector, which means now velocity is only the acceleration, which is only the gravity. Then you reset it to 0. So that way, if you just set it to 0 and then subtract it, you're just subtracting by 0. So it doesn't really do anything. This is the last loop's movement vector. So velocity is like 300, and your movement vector is, let's say velocity is 300, 200, and your movement vector is 10, 0. So that will just decrease your movement vector, and then we set it to 0 so we can get a new movement vector based on the keyboard presses. Okay, so left, right, you've seen this before. Up, I made it a little bit faster, so it kind of broke the gravity. That way the gravity wasn't matching the up. So you can go past the gravity that way. That's why I multiplied it by 1.5. Delta time, I just grabbed a local float from the game time.elapsed time.total seconds. That way I don't have to do that repeatedly. Velocity is equal to movement plus acceleration. Position is equal to position plus velocity times delta time. So it's a little bit smoother on the updating the position. Now we check the screen bounds, and this is a lot easier to detect than it was on the other side of the map, which I'll discuss later on. So if position, you've seen this before on the basic training series, if it's less than 0 on either the X or the Y, it means it's outside of the game window on the left side or the top. So if it is, just set those values appropriately. If X is less than 0, set it to 0. If Y is less than 0, set it to 0. That way it can never leave the top or the left side of the game screen. Now we populate the bound points. And we look at the populate bound points here. We clear it because we need to repopulate it. Of course, the position, which, if you see the basic training series where I talk about the origin, I think it was the position, the vector 2 vector tutorial, I talk about the origin. Now the origin currently is still the top left, so that's why I'm using position here. Because we want to get the position, the points, top left, top right, bottom left, and bottom right. So we want to get these points. So that's the top left. Now we need to get the top right, bottom right, bottom left, and then the bottom right. So that's the bound points, just little corners of the tile, little corners of the texture. Okay, so after we get the populate bounds, we need to get the point location. And what we do here is just the location that we will depopulate the collision points. The location of the points to check for the collision. So we get a point location. We get the tile location of the first bound point, which is just the top left. And then we clear out the collision points and we add the location. What I did here is I wanted to make the collision detection a lot easier on itself than it needed to be. The reason I'm doing this is because you could be halfway between, let's say, your character is in between these two tiles right here. So you need to check these two tiles for collision. You do not need to check 4, you just need to check 2. So that's why I did a little complex collision detection here. For int I is equal to 1, it doesn't need to be 0 because we already added the first one. I is less than 4, there's 4 items in the list. I++. Location, get the next tile. If not collision points that contains the location, which means it's a different location, we add it. If it's the same collision, we're already going to check it. We do not need to check it twice. So there we go. We do not add it. Okay. So that's what we're doing with the collision points. Is we might have only one collision points because it's in exactly the right spot. So it's only colliding with one single tile instead of 2. Alright, so now let's talk about the handle tile collision. This is what is going to happen when the map says, oh, there's a colliding tile point, and I'll pass you the point and you handle it. Who handles it? Whoever collides. In this case, the player. So we have the player point and the point of the tile that is colliding. So here is where it got a little bit tricky. And what I did here, it's a very simple technique. You can make it as complex as you want. There's various ways to do this. One of the ways is to get the center of the player and center of the colliding tile and calculate the distance between those and the minimum distance you can achieve and subtract that and you find the depth. I chose a little bit simpler technique for you guys since I'm not really going in depth on this tutorial. I probably went as too far as I should have. But anyway, we calculate the depth and the depth y. Now, why am I doing this with the float max value? Is because the depth needs to check whichever is smallest, we will push out. I couldn't do float dot or couldn't initialize them to 0 because one of them might be 3 and the other one will just be 0. So I did max value is detect whichever depth is the lowest, we need to push out that location. It will just adjust the position to push it the opposite of that direction. You'll see what I mean later on. We calculate the center of the player. So position x plus texture width divided by 2. Position y plus texture height divided by 2. And the same thing with the center tile, the colliding tile. Now we get the angle between the two. The angle between the center of the player and the center of the tile. So If you draw a straight line from those two, that angle is what we're getting. Now we check velocity. If velocity x is less than 0, which means we're moving to the left, we need to set the depth x is equal to tau x plus tau width minus position x. And that's different between this is because if velocity is greater than 0, which means we're moving to the right, so we need to check the right side of the texture. And you've seen this done many times before. Position.x refers to the top left, or the left side of the texture, not the top, because we're not using position.y. But the left side of the texture, then we just add the texture.width. So now it's on the right side. Same thing with the y, exactly the same thing with the y. Now we just check the absolute value of the depth y is less than or equal to the absolute value of the depth x. We increment the position plus new vector 2. We just increase, we push the position on the y-axis by the depth. Otherwise, if it's greater than that, we push it in the x direction by the depth. It's positive, so we push it. And this doesn't need, you do not need an if here. I used to have it like this. That's why the if was still there. You can leave it if you want to. And then draw, we just draw. Okay. What's next? The map. I didn't really change that much with this. Of course, I added the collision here and collision detection here. But that's pretty much all that is. And of course, the spawn tiles and all that stuff. Alright, so read file is identical. Kinda, I just added this if. So if the current character we're looking at equals to the spawn tile, we just set the spawn point to that location. And of course the spawn tile does not have any visual representation in this tutorial, in this sample. It does not have any visual representation, it's just going to be an empty tile. So that's what we do, we just set it as an empty tile. Add region is the same, add background is the same. Check collision. We have the moving tile location, so the player. You might have like a coin that jumps up and down, and you want to check collision so it knows when to move up. So a moving tile, or a moving object, the location of that. If that location is greater than x, or if that location .x is greater than the map dimensions .x minus 1, and minus 1 just gives us a little error that we can be assured that it will not go outside the game window, it returns true. So there is a collision if we're moving to the right, moving to the right, moving to the right, and we've reached that side of the game window, it will do a collision. Otherwise, and I duplicated that issue here. As you see here, it's almost identical to here, except for it's less than. And the reason I did that is to check to see if the x value and the y value are less than the maximum values. If it is, we can do this correctly. If it's not, you'll get an array out of bounds exception. Okay, so if that location does not equal empty tile, everything else is collidable. You can collide with anything else but that empty tile. Now, if you want to build this and create your own game, you might have collectible tiles and stuff like that. In that case, you can create your own tile object class and go from there. So, if it's anything but the empty tiles, we return true. If these two are not met, we return false. Draw is the same. Draw tiles is the same. Alright, so I think that's it for the code. Now let's demonstrate it. Now, you see it falling. I set the initial position to there. And you saw the collision just there. So it does have gravity. I'm not touching the keyboard now, so it is falling. And you see the gravity is still there because you see the red, that's a collision indicator. So the gravity is still acting on it even though it's just sitting there. That is the way to do that, because you can detect it fall if you just move over here. I tried this with the Boolean value for is jumping. I just press up and it'll just jump like that for a split second. You can't hold it and just move around and stuff like that. This is kind of a testing for the collision. So that's why you can move anywhere you want to. Okay, so I had a Boolean jumping value. So once I dropped down here, I'd set it to false. That way I didn't have to keep on saying collision to collision, 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 collision. Oh, I'm seeing red, collision, collision, collision. You just stop here and then you see the normal stuff that you see here. But of course, you're not jumping, so you do not use your gravity. You just be stuck here. So you move like horizontal. My mouse disappears, but you can see it on the screen, I believe. It just wouldn't move. It wouldn't drop down here. It'll just keep on going on the right side. Okay, so like I said, the outside of the game window on the left side and the top, that is handled on the player level. So if I'm still holding up, I'm still jumping, but I'm not getting a collision indicator. That's because a player is detecting the bounds for 0 and 0. If I move up, I see the tile. Okay. Alright. Now, if I move right, there is a collision indicator. I'm still holding down the right key, so there is a collision indicator. Now, I'm going to let go of the right key right when I start falling. There is no collision indicator because I pushed it and pushed it by 1. So that way I'm definitely outside of that collision. So this isn't the perfect collision detection. This isn't a perfect system. This isn't a complete game, so I didn't spend a whole lot of time on it. There is some issues going on with it, but it should get you in the right direction if you want to create a platformer. Yeah, that should be it. That should be it for the maps tutorial and the tile collisions. You shouldn't see any more tutorials on that later. That should be it for the platformer style type game and graphics and stuff like that. If you want me to create a platformer game, just let me know. Of course, I gotta get my tower defense thing started first and finished. But after that, I can be open to ideas on what game to create next. Keep it 2D, please. I don't want to spend 500 hours on a single 3D object and do a tutorial on that. I mean, these graphics took me about 10 minutes to make. I'm very quick on 2D. 3D, I still am not very quick at all. Alright, so this should get you in the right step if you want to create a platform type game. Just look at the source code, use whatever you want, however you want. I do not care. It's not commented because I do this video. It's like a line by line comment type thing that I mentioned in the first part. So do not comment the code. Okay. So let me quit that before I start playing with it some more. Alright. So that's pretty much it. It's not as object-oriented as a full game. If you're going to use this as a full game, I would not use the char array for tiles. I would create a tile class, so that way you can have, a collectible tile, a wall tile, a nothing tile, like the empty tiles, a enemy tile. So that way you can detect, there's a collision, but I do not do the collision detection. I do not push the player if you collect an object. you do not move the player's position somewhere. Now if you intersect with the block tile, of course you push the player. And like I said, the pushing of the position, that is the most basic way I could think of to do this. The easiest and simplest way. Otherwise, it gave me a lot of issues. I had to spend a lot of time on this. Had to write up some stuff on the whiteboard and kind of think things through a little bit. Kind of balance it out. I was getting ready to do the complex way, but then I just stuck with it and tried to find the best way to do this. And of course, populating the bound points helps, because that way you get to update the collision points, and if you have the same bound points on all four, you only need to check collision once. You do not need to check collision on all four corners of your texture. Okay, now let me just demonstrate that this does work. I'll put that here, and I'll put it here, so that way it just stops right away. Right on the B. There we go. And I'll quit that and put it right on the B at the very bottom. Now I haven't tried that out. I actually should have tried that out. Let's put it above the A down here. Let's see what happens if I go down the game screen. Yeah, I'm pretty good about making sure things work, even though I haven't tested them out. Alright. Now let's close that. I test my code on paper and in my mind before I write anything. Which is the way you should anyway. Just test it out. Throw various inputs and write it out on paper, line by line. And there we go. So we verified that the start location can be changed, and there's the platformer. So, I hope you enjoyed this tutorial. Next tutorial, I do not know what it'll be. It'll be a surprise for you guys. So stay tuned for that. The tower defense series should be starting out in a few weeks, so stay tuned for that as well. And the next tutorial for this weekend / Monday will be there's a screen system I created, and I'm doing a video guide on how to use that. Not a tutorial, not a line-by-line walkthrough, but an actual guide on that. So, YouTube members, if you've watched, I should have mentioned it at the very beginning, I'm sorry. If you've watching this video, the download link for the source code is in the description. The premium members, the download link is at the very bottom of the first initial post, right under download video. You just have download link, download source code right there, right next to it. Alright, I hope to see you next time.